Alrighty, CNT140, Chapter 6. We just got done mentioning about submarine cable. Like I said, I've shared some of these maps before. Here's a link to one you can actually see kind of in real time where cables are and what they're called and where they're connected and so forth. Just kind of a fun idea to look at if you have a minute. Next type they mentioned is air-blown fiber. And really the idea here is you're basically installing ductwork, and then that allows you the ability to add fibers later without having to like dig up intersections or trenches between buildings or so forth. So you're installing these tubes, and then for installing the fiber at a later date, you actually use pressurized air through that tube, and that helps reduce the friction of putting the fiber through. So you're actually pressurizing that tube and then installing the fiber through, and that's helping to reduce the friction of, you know, you're almost floating, I'm using air quotes there, almost floating the cable into the tube. And that allows you to add links as you need a later time with minimal disruption, digging things up and so forth. So here's, I can basically pressurize and pull out the old fiber, pressurize them, and put the new fiber in relatively easily. Hybrid cables, there is some hybrid cables where you would combine multi-mode and single-mode fiber together in one jacket. Sometimes that gets used because you need the multi-mode now, but I'm putting single-mode in where I might use it later. That's the idea here. And this actually is multi-mode and a single-mode in one jacket. It's kind of hard to see, but they are there. Composite cable allows you, or as a style, that you now have some power lines as well as a data line. And they give you some good examples here to understand when you would use that. Underwater tethered vehicles, because you need to send controls to the motorized, either the tracks on the bottom or the propellers to move it. But then I also need data from maybe a camera to receive pictures back, etc., data back from it. So I have the fiber plus the power lines all in one jacket. And here also showing you wireless antennas or closed circuit television cameras. I can tilt, pan, zoom, etc., in addition to powering it. So there will be a composite cable. Now these, since I do have power as well as data, these need to be grounded and bonded. That would be something to consider. Or something that needs to be engineered in. And here it shows you the power as well as the data on each side. Criteria then, the cable you're installing, we need to worry about the pulling strength. Any outside plant, or I should say inside plant, you're typically laying it in trays or things that are kind of in place already in the building, so your pulling strength is not a huge concern. It still needs to be, you still need to be gentle with it, but it's not a biggest concern as dealing with outside plant. With outside plant, I might be pulling cable through 2 or 3 kilometers of conduit, and even with using pulling lubricant, which is there to reduce the friction, you can still have, I think they said in there, something, 800 pounds of pulling force, if you will. Basically a half ton of pulling force, and installing the fiber through those conduits. So anytime you are pulling, we're remembering we have the strength members here, the aramid yarn, the Kevlar. That is what I'm using to tie onto, because that's designed not to stretch. Meanwhile, the jacket would, or the fibers on the side would break if you put a lot of tension on them. So as I'm installing fiber, I'm tying onto the aramid yarn. This shows you the, you kind of weave it through the swivel eye here, tape it back on itself, and I'm now going to pull with the strength fibers, not the fiber itself. Bending radius limit. As we're installing fiber, we're doing nice gentle bends around corners, and they're reminding you here of under tension during pulling, the bend radius is 20 times the diameter of the cable. I should have it nice and round. Once it's not under tension, that bend radius should be at least 10 times the cable diameter. So we need to remember as we're installing, we're keeping it nice and round, but when it's stationary, just laying in place, it still should not be a tight corner. There is a reminder here about bend insensitive fibers would allow that to be a tighter bend around corners, especially in closets and so forth. Water protection. Water protection is usually done with one of two things. The cable itself is pumped full of a water blocking gel, or some use that tape we looked at earlier, or some use a powder that is similar to the absorbent material that's in like diapers and so forth. And those are all there to protect the fiber from having a lot of water around it that would deteriorate the fiber a lot quicker than just as it is. So our fibers, as we look at them, here's an aerial one. It's showing you in here about the water blocking system, and sometimes you have it out here, and then in individual breakout tube too. Crush loads or rodent protection. We mentioned this a couple times already. Anything that would be installed maybe underground or in an area with a lot of rodents or things like that, the fiber itself should have that armoring on to protect against those, either the crushing of the soil on top or rodents that might be chewing through. Fire code ratings. As I move cabling inside, I need to worry about the fire code ratings, general, riser, plenum, etc. And in the US, they remind us about the National Electrical Code, Section 770 has that broken out. Now, in this chapter, they gave us some additional codes, if you will. Optical fiber non-conductive general, optical fiber conductive general. Conductive if we have that like armoring. If I have any kind of armoring layer around there, or maybe a strength member layer in there, okay? So I might run into the OFCG, the conductive. If it's conductive, I need to do grounding and bonding. But for the fire rating issue, we're looking at that last letter no matter what. General, that would be patch cable use in a closet. R, riser, that could be used between closets vertically from floor 1 to floor 2. And then P, plenum, this would be used for, above the ceiling, down the hall and into a room, maybe connecting 2 rooms together, or even fiber to the desktop type of thing. Watch the code on the side of the jacket, OFNR riser, OFNR, I think it over is, OFNR right there, riser. This one actually says OFNP, but plenum over here it says. So make sure you're using the correct style for the install being done. And then they remind us, if I do have any of those strength members or armoring here, that needs to be grounded and bonded. And there actually is, you're actually bolting the ground wire to that shielding, that armoring, and that eventually needs to get in your closet connected to the grounding and bonding point in the closet. Color code, they remind us, outside, pretty much de facto, black is the outside jacket color. And that's there for, as we said, UV protection, water protection, so forth. Inside, typically, the de facto standard was yellow jacket for single mode, orange for multi-mode. But our multi-mode fiber inside has developed over time and advanced over time. So we now have the OM1 orange, OM3, your aqua color, OM4, your violet color, OM5 lime green, and single mode inside is typically yellow. And then don't forget the connectors on the end can help you with identify the type of fiber that's inside as well. What type of 50, 125, 62.5, whatever it happens to be. They also remind us when we have these loose tube fibers or ribbon fibers, which we'll look at in a second, there is a color code in there of fiber 1 is blue, fiber 2 is orange, fiber 3 is green, and so forth. That allows you to identify on each end what fiber you're dealing with, especially as you're terminating to a breakout box or something of that nature. That color code still gets followed if you have a large fiber count. If I look at each tube, there's 12 in there that are color code, and then in addition, each of these tubes of 12 is color coded, following the same blue, orange, green, etc. There's your 12 tubes of 12, so there'll be 144 fibers there. So they follow the individual fiber color here, and then if I have a large fiber count, I start the color code gets followed for the tubes as well, the breakout tubes. If I'm dealing with ribbon cable, I have the same color code indicating each of those fibers, and then they would get stacked on top of each other in there. I might have 4 or 5 stacks on top of each other of those 12 fibers. But the ribbon cable follows the same color code. Last but not least, choosing our cables. I have to think about the install requirements. what are needed, whether I need the high pulling tension to be able to pull it through long distance conduits, or environment when it's installed and sitting there over a period of time. Do we need the environmental protection of waterproof? Do we need the environmental protection of, the armor for, critter chewing through, etc. So I need to think about when I'm putting it in, as well as when it's sitting there over a long period of time, which is why all of these options were shared in this chapter, letting you know there's lots of options for different applications. So there is our chapter on our fiber optic cable.